Hey, there we go. Aw. I'm going to move over here now. Hey, everyone. Welcome to the stream. Happy Friday or Saturday, wherever you might be. Oh, we're going to get into the Apple IIc schematic really quickly, but we're going to do a slight detour before we get there. But hey, Nintendo Ramsey, good to see you. Meyer Makes. For those that don't know, Meyer Makes is also Clem on the Element 14 Presents channel. Does all the, well, he as well as others do awesome projects, but he's my favorite. What's the ADC board? Hey, Alex. It was something I called the Visual ADC, which actually confused a lot of people because they thought it had something to do with vision. But it's basically an SAR, or successive approximation register analog to digital converter, that basically you can watch it go through the binary steps to digitize a waveform. And I think we did 4 bits, which it could go wider than that. It just starts to become kind of impractical at that point. I mean, it's already impractical as it is because it purposely goes really slow, but that's what that was. So, hey, RJ Helms, good to see you. Retrotech Dan, I saw you pop in. Ian, it's been a while since I saw your name. For those that may have not been around for a while, I went back to streaming on both YouTube and Twitch, so that's why I started putting the chat back into the stream, just because I realized it almost would look like last week. I kind of like was watching the stream in my own eyes, and I thought, wow, it looks like I'm having a stroke because I'm having a conversation with nobody. So, okay. With that, I want to get into the project, but first so on the Mega 2E, it has the IWM chip from the Apple IIgs, which was also in the Apple IIc, and by default, that chip acts like a old school Apple II disk card. I've been trying to figure out how to get the ROM from the Apple IIc into the Apple IIe ROM that I'm using, so that I can use that chip to talk to hard drives and 3.5-inch disk drives. And right before the stream, RJ Helms gave me an idea, and I'm chasing it down real quick because I've gone through the Apple IIc firmware, and I've been doing this for a couple of weeks now. I mean, technically I've been doing it for months, but the last couple of weeks I had a couple of aha moments, and I'm looking through, I found the chunks of the code that I think we need to copy into the ROM, but I don't know how to get to that code. Like, I don't know when the 2C ever calls anything. And so now I'm realizing I'm not going to be able to talk and do this at the same time. See, this is actually interesting, because this is the ROM. I realize you might not be able to see over here, but I just saw this thing about tape. Oh yeah, tape. Okay, wait. It's funny because this ROM, this section of the code, started in the Apple II, and it's been modified for each generation of Apple computer. And the 2C has some stuff specific to the 2C, but some of the stuff isn't. And that's what I'm trying to find, is where does it say, hey, do we have a disk drive or not? Because I have a feeling that's the thing I want. Okay, and I'm at the end of the bank. Shoot. Okay. All right. I'm not going to go through that now. Let's get to the real thing. Oh, I need to fix one other thing. There we go. Yep, that's in the wrong place. Let's fix that right now. All right. Try to keep an eye on this because this was broken last time. I'll do that and that. Oh, okay. I just realized what, Clem, you're saying. What are you working on? New Element 14 project, of course. So, okay. This is still not the thing that I want. I keep opening the same thing. I'm looking for schematic diagram of Apple IIc. There we go. This you guys can see. Okay. Let's get this zoomed to about 400 was I using. Okay, and then let's load up the KiCad and we'll get going. So all this is part of the bit preserve project. I'm going to try this. I don't know if this is going to work. I'm going to try links through Restream. And I'm curious if it actually, oh yeah, because it's posting as me, not as Restream. Perfect. That worked. Okay, that works. Yeah, that's good. Okay, so let's go projects, golden delicious. No. Projects, GitHub, bit preserve, Apple. Oh crap, am I in the right branch? Yeah. So I already talked about this before, but I'm gonna talk about it again. I have, where's it at? I've got a button just for this. I want to make sure I use it. Oh, maybe I never set it up as a button. That's dumb. I never did. Oh, there it is. So it really bothers me when people get all upset about KiCad versus KaiCad when they spell it with capital letters, because regardless of how you pronounce it, it's only spelled one way. It's a word. It's not an acronym. So if you capitalize the A and D, you're misspelling KiCad. Which I'm just waiting for somebody to tell me I'm saying it wrong when they spell it wrong, because multiple members of the development team have said they don't care how you pronounce it. KiCad or KaiCad, doesn't matter. Different regions in the world are going to pronounce it different. However, it is spelled specifically one way because it is not an acronym. Okay, I'm done. Now we can get back to work. Kind of offensive. Yeah, I try not to do that, but sorry. Oh, is that not turning off? There we go. Okay, so I am in my branch. I need to pull down. Well, I'll do it later. Okay, so Apple IIc, KiCad, and schematic. All right, now I'm going to put that. Whoa, what are you doing, Windows? I swear. Shoot. Oh, I don't know how. There we go. I'm going to go right back into rant mode. I just can't believe how brain-dead Windows is sometimes. Which is understandable. I mean, it's a relatively new piece of software from a company that has almost no engineering resources. So it's not surprising that somebody hasn't had time to come up with the logic of how Windows should resize if the resolution of your computer changes. I mean, that's a totally understandable problem that even though virtually every version of Linux and all of Mac OS has always done correctly, I can understand why it's taking almost 40 years for Windows to figure out how to do it. I mean, that's understandable. I get it. Well, CAD itself does refer to computer-aided design, but that's not what the name is. The name is just the original creator was talking to a friend of his, and they came up with a name for the software. And so the name KiCad does not stand for key computer-aided design. It's just a word, and that's why it's not capitalized, because it's not the acronym CAD. So yeah, in the case of the name KiCad, no, it does not mean CAD. Now, it turns out it is a CAD program, or ECAD, or what's the other word? ECAD, EDA. I mean, EDA is probably a closer software or closer name to what it is, but yeah. Anyway. Okay, so we already did, and I went through and I looked it over, and I'm pretty happy with it. We did the first page, which is basically the CPU page with a couple of the ASICs and all of the RAM. Strike that. And the main data, what do they call it? The main data bus, or the main bank. Is it bank? Every time I refer to memory as banks, I think of Star Trek 2 because that's when they started saying memory banks. And that's always bothered me. So, yeah. I mean, you know, there's certain things that I will rant and complain, like I can't believe that Windows does this. And you know, and sometimes I can kind of say I'm only being a jerk because it's like it's a really hard problem to solve. But I don't feel like the resolution on I just don't understand it. And it's so bad. Like, why doesn't every application force the menu bar to always be visible? Like, that should never disappear. Or there should be like a way to like right click on the border of a window and tell it to do something. You know, that, oh God, I'm getting all flustered. Okay, so what do we have here? We have a couple of latches, which I think I already named. And then I think this is the aux data bank. Aux RAM. Main RAM, aux RAM. Okay. And then down here we have the character ROM, which I think I've already created. Rough look. No, that's something's different. A10 is different. Why is A10? Okay. I might have copied this one from the 2E schematic, which... Okay, this one isn't the same at all. Wait a minute. Hold the phone. I'm missing all the address lines. Okay, so this... Okay, well, here we go. We'll start right here. So what did I do? I created a... I want to do change symbol first because I want to see what it is. Oh, it is using the 2E. Okay, so that's what I did. So what we got it, and then let me go check my library and see if I added a new one. Maybe I got the wrong one. The enterprise would be bank switched. You know, I was thinking about this. And first, one of my pet peeves is when people say how Star Trek predicted the future. I mean, science fiction has been doing, that kind of thing has happened lots. But I did think of a very interesting comparison between the original series and Next Generation in terms of personal devices. In the Next Generation, and I'll throw DS9 and Voyager into that because it's all around the same time period in universe and out of universe. You know, when they carry around things like pads or any kind of storage device, it's always this big bulky thing. Now, obviously the reason is because it had to be visible on television, but I got to thinking it's really interesting that they kind of claim that these big memory chips are what you would be using 400 years from now. When in TOS, 300 years from now, they just had the little plastic cards, which as a kid, I thought, how ridiculous is it that you're going to tell me that this little plastic card contains video data? And then you kind of think about today and SD cards and stuff, and it's like, wow, the original series was way closer to the direction we went. That as silly as it was that they were putting a piece of acrylic into a slot and calling that memory storage, it's like, wait, that's pretty, from a high level usability perspective, that's what we have. Obviously inside of it is silicon and you got the metal contacts and everything. But I'm just saying from the user's perspective, it's just a plastic card you put into a slot. And I just think it's interesting that in TOS era, that was memory storage. And then when you watch some of the TNG stuff, they have the isolinear slot things every once in a while, but there's been a couple of episodes where they have like a brick. And it's just interesting. Okay. Apple KoolAid. One rant per work session. Yeah, I try it. I don't know. Overall with content that I create, I try to keep things more on the positive side. I think we have enough people with engineering backgrounds that just get on in front of a camera and complain about things just to rile up their audience. And so I at least try to keep my rants to stuff that doesn't really matter. I'm not perfect at it, but at least that's my goal. Okay, so I guess I didn't copy this one yet. So let's start there. So we have the Bit Preserve project, which has at least a dozen different computer schematics in it. And RJ Helms, who might be in chat, well, he was earlier. I'm just saying he might have come. I don't know if he's, anyway, did the Apple IIe. And so the 2E and the 2C share a ton of common hardware with slight variations. And so what I'm doing is I'm basically copying his chip or his symbols over into our schematic and then updating them for the 2C schematic. And so I guess I had actually done that, but I forgot to change the reference. Okay, so now we can edit, go to edit library symbol, and now we can get to work on this. Yeah, I think KiCad makes more. I think KiCad is careful what I'm saying. It's understandable because of its origin, but I think, as I've heard people on the development team say, they recognize different parts of the world pronounce letters differently, and so in Wayne, and so here I'm going to say his last name wrong. Is it Stahlbaum? Anyway, Wayne, the lead developer. The lead developer, his quote was my favorite so far. Is he said, "I don't care if you call it KiCad or KaiCad as long as you're using it." And I was just like, okay, that's the kind of attitude I can get behind. All right, so pin 1 is going to go up here, then 26, 27. Boy, this is a totally different chip. That is suspicious to me. I wonder if it's not a 2732 and they lied and that it's only a 2764. Because none of this lines up. All right, so we're just going to start over. Here's what we're going to do. Let's go into the pin table, and pin 1, I don't know what pin 1 is. Okay, this might not work either. But I know it's not. Okay, so I know pin 1 is not that. And then I have a pin 26, 27, and 28. I assume 28 is VCC. 25, 26, ARG, 27, 28, BCC. Not figure this one. Yeah, if you actually look on KiCad.org, you will find almost no time that it's uppercase AD. I mean, it's very, well, I'll put it this way. I haven't found an instance of it, which isn't to say that it doesn't exist, because maybe there's probably somewhere that it does. But yeah, because I do a lot of writing, especially about companies, that's something that I'm always really sensitive to. Also, when I worked at Kemet was an acronym, but we pronounced it as a word, and I forgot what the name of that is. But anyway, it irritated me that people at our own company would not spell it all capitalized, even though it was an actual acronym that just got turned into a word. And so, like, our actual brand was a capitalized word. And so now that I'm I write about a lot of companies, that's one of the things I pay really close attention to is how do you spell your company's name, because I'm sensitive to it. Okay. I'm just going to start over. All right. So this is going to be ground. And then this way I can go to, but that was something I noticed a long time ago, is if you go through KiCad.org, it's not spelled with capital letters. And then at some point, and this was probably before version 5, I even asked in the KiCad IRC if there was a preferred spelling. And it was sort of the same thing. It's like, we don't really care. Like, it's more important that people are using it. I got confused. 25 is A8. But the correct spelling is not capitalized. And like I said, the only reason it even remotely bothers me really is because how many people get wound up about KiCad versus KaiCad when it's like, it's okay. Longtime viewers are like, oh my God, next he's going to start talking about capacitors. The list of places I worked at is getting really long. It's actually not that many. Hey, Sudo. I just saw what you wrote. Like major jobs, I've only had 2. And when I mean major places I worked, so I worked at Agilent for over 10 years, or right at 10 years, something like that. 10, right around, it was between 9 and 11. The problem is I left for 9 months to go work at LaCroix. And then I got laid off. And so I don't quite know how to count it all up. So that's why I say 10, but I could be off plus or minus 1 year. And then Kemet, I was there 7 to 8 years. And then almost every other job I've had has only been about 2 years. So one was a startup that it's still one of my favorites to talk about, because our CEO decided he wanted to have a strategy set. So I was hired as a technical salesperson, and he wanted to have a strategy session on how were we going to grow our sales territories. And there were 3 of us at the time for the entire United States. And so I knew one of the engineers really well, and with his help, I understood what our roadmap, what his plan was, what the product roadmap would be. And so I laid out a plan that said, until this version of the product comes out, it's going to be very dry in my territory. There just aren't that many people for the product we have. And then I said, but once it comes out, here's what it all looks like, and here's what I can do until we lead up to that time, and blah, blah, blah. So after all 3 of us present how we're going to position our products, we had 2 major products. And like I said, one of them didn't really apply to my area, and the other one did. And the CEO goes, okay, so we're going to cancel the Datacom project and focus on telecom moving forward. And I was like, I don't think I'm going to be here for much longer. And then 3 days later, I got the phone call. It's like, okay. Because, that was like a case where I didn't realize that's what was going to happen. And I literally dug my own grave, because I just laid out and said, look, hey, as long as all we have is the telecom product, I don't have a market to sell it to. And he was like, okay, well, then I guess we don't need you. I was actually kind of irritated by it, because I was like, if he had told me that's what was going to happen, then I would have approached the problem different. But anyway, doesn't matter. Kemet was the capacitor company. Yeah, all capital letters. Nice try. I see what you did there. Yeah. Initialism is what I was trying to think of, Ian. So you think acronym is when you say the word, say it as a word, and an initialism is when you say the initials. Yeah, okay. I was thinking it was opposite, but that doesn't make sense. So, did it stand for something? Yeah. So Kemet originally was a part of Union Carbide. Union Carbide got its real start in the electronics industry by making getters for vacuum tubes. And then sometime around the 80s, their chemical and mechanical division was becoming quite, had transitioned almost entirely to tantalum capacitors. And then they were also doing some ceramic and some film, but the key was tantalum. That was making all the money. And so the division got renamed to the chemical and chemical and metallic division, or chemical and metal, not mechanical, metal, which makes more sense. And so that got shortened to KEMET. Now, astute people would say, well, wait, chemical started with CH, so how do you get to KE? The reason, and this is a little bit up for debate, but the CEO at the time, Mr. McGuire, was a fanatic reader, and he knew quite a bit about Egypt. The ancient word for Egypt is Kemet, and the rich, fertile black soil along the Nile is sometimes referred to as Kemet. Tantalum powder, once it's been processed out of coltan, is black powder. And so the connection was that the word Kemet represented lots of different things depending on which language you look in, but it effectively was black dirt that had a lot of life. And in terms of the company, that black dirt, which was tantalum, offered a lot of life. And so that's how it got turned into KE instead of CHE or whatever. So, which is interesting because, or an interesting side note of that is when I was there, I helped run what we called the Kemet Institute of Technology, which was a series of technical seminars. And almost every year we would do the series, we would get somebody from Egypt would sign up, and I think they got confused. Like the first time, I couldn't figure out why. And then after I heard the Mr. McGuire story, I was like, oh, I get it. And then I went through some of my pictures from when I was in Egypt, and I actually found at some point, I took a picture of like some building, and it had the word Kemet on it. And so I was like, it kind of like all came together. So, okay, so totally unrelated to anything, but well, related to what I just told you. So to me, the really interesting thing about the Kemet story, right, is the name came from the fact that we were the chemical and metal division, right? And then we combined the two words to come up with a name. One of the biggest projects I worked on while I was there was the acquisition of the passive division of NEC, which was NEC Token, Tokin. Now I'm going to get this mixed up or slightly messed up, but the core of the story should be accurate. I don't remember the Japanese words now. But Token was originally its own company that got acquired by NEC, and then NEC sold them to us. The word token comes from the TOK or KIN. I can't remember which, but one of those words means mountain. They were based in this town that was in a mountain, and the other word means metal. And so the word token was basically the same thing. It was two attributes of the actual company that were combined together to form the name. And I thought that was super cool that both of our companies were kind of named that same way. Turns out I'm the only kind of nerd that in a group of big nerds, I was the only nerd that thought that was worthwhile. So anyway, whew. Yeah. Okay, so I saw somebody said they're pretty sure that this has to be a 2764 EEPROM. I'm going to say EEPROM just because I want something that has a pinout. Even though this isn't an EEPROM, but the pins are more or less going to be the same. because I want to know which pins are which, and I don't remember. I don't want to sign up for your newsletter. All I want is your data sheet. Well, I don't know why, but I think in technology, I find how things got named to be interesting, sometimes more interesting than the actual technology, just because it's something that most engineers give no thought to. And it's always interesting to me, especially in technology companies, when the name has a meaning associated with it. So, all right. So now I realize I don't know what VPP would be on a not EEPROM. But, oh well. So 20 is definitely chip enable, which we're missing pin 20. 1, 2, 3, 4. Whoops. 20. So this is probably going to be chip enable, and that will be an input. And then 22 is, oh, I see what I did. I have two 22s. Okay, that's fine. And that's going to be the output enable. Okay. And then 27 and 1. Okay, I'm just not going to name them because I don't know what to name them for this. VCC, ground. All right, so what else are we missing? So, oh, now I can go in order. So 12, 7, 6, 5, 4, 3, 2, 1, 0. D, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. With ground in between. And then 19 is 7. Okay, then 20 is an enable. 21 is the 10. That's the other enable. 11. 24 is address 9. 8. This is a no connect. And then this is VCC. Oh, no. This is, I don't know what that is. And then that's going to be VCC. Yeah, Nippon, Kimikon. The other one, like the other one is Ichiban, Japanese beer. Ichiban. Ichi is 1 and Ban is beer, so it's #1 beer, which I think is so funny. I just think it's like, okay. So, Lorenzo, you're going to name your projects. You got to stick to a project, a theme. So I'm not gonna be able to show it, but so I have about 20 SD cards that I cycle through because I'm usually recording multiple things at once off of multiple cameras, and all of my SD cards are named after Star Trek characters. So, which I don't know. I had wanted to make, if I ever owned a company, this was when I was in my 20s. My plan when I was in my 20s. If I owned a company, I was going to name all of the conference rooms after ships from Star Trek. I just saw your comment about cache invalidation. Okay, so we're going to do that. So now we've got a massive mess for the pins. So I'm just going to move these over here. And let's see. How are we going to do this now? I wish this had... Darn. I was hoping this would have the hotkey PCB has, where you can hit T and then just type in the designator. And then it snaps to your current position. But no. So, okay. So I can probably minimize that now. So we know 1, 26, let's see, 24 is going to be somewhere around here. 26 and 27, darn it. Let's see, what can I do here? What's going to be the best way to do this? If I go like this, it'll get nothing. So maybe if I go like that, no. Yeah, that's not going to break them up. I just have to break everything up. Okay. get that up there. This one's going to go down here. This one's going to go somewhere over here. I have to make this symbol bigger. More big. Those are almost in order. Output enable is 22. Okay, so I must have these backward because output enable can't possibly be tied low. That makes no sense. Right? Because this is, oh, wait, maybe it does. I'm going to look at another data sheet and see if it actually gives me a different nomenclature. I have 20. This one has 20 as chip enable and 22 as output enable. Okay. So at first I thought it was weird that it was always enabled. However, it's going into a selector. So that's not quite as weird as I thought it was going to be. So I just think that was because I think it makes sense now that I see it, because it's going into this 166, which I don't know, is that an encoder? Must be an encoder or something. Oh, is this the shift register? This is the magic shift register, I bet. Yeah, okay, duh. This is the shift register that makes all the magic happen. This is how you get magic video, because I can tell now, because this goes through the shift register, that goes the vid out. Where's SIR-out connected to? Yep, okay. Okay, that makes sense. All right, so D7. I guess we'll just do these one at a time. Why does that have a negative on it? Okay, I'm not going to worry about that at the moment. I'll fix that in a minute. It must be holdover from the previous pinout. 6, 5, because I'm going to do, we got to change them anyway. 4, wait. Okay, yeah, they put these in order. 3, 2, where is D2? There it is. That's not it. That's it. That's better. I'm going to put this up here, I think. Yelp. And let's see, D1. That's not on the right grid, but I'll fix that in a minute. That's not what I'm too concerned about. All right, so let's move these all up so that I can space them correctly. All right, so first up, let's get these to not be inverted. And these are not, oh, that needs to go up one. These are not inputs. So what I'm going to do is I'm going to X these. We're going to go into Sublime. I'm going to paste these. We're going to hit Control H and say pin input to be pin bi-directional. Although in this case, we could probably just call these all output, since actually, to be correct, these are TriState. So we will replace all, and then we'll cut that back, and then I'll pick, oh no, shoot. Okay. We're going to make this one TriState so that I know what the correct word is. So we're going to X that, paste this, Control H that. I want to change pin input to, oh, it's try_state. Replace all, cut that, paste that, and there we go. That was much easier than doing it one at a time. Was I singing the Jamie Tartlett song and you thought it was like D3 Jake? Hey, D3 Jake, good to see you. Hey, Balika. Yeah, so output enable on this design is tied low because because the shift register has to run all the time. If I had to guess why, I don't know. That's my guess. Which now I have a question, because chip enable enables the address decode logic. Output enable enables the output. So I guess what could happen, we'd have to look at the data sheet, but I guess if the chip is not enabled, but the output is enabled, then it must just output the last valid state, right? And then it's not until you enable the chip again and then give it a new address that the output changes. That's my guess. And as we know, whenever I guess, it is always right. There's no reason to question it. Don't question it. It's right. It has to be right. Okay. Let's go pin 12. Where are you at? No, I want pin 6 now. And pin... Oh, I get what's going on too. So this doesn't even have address bits 1, 2, and 3. Because I'll bet those go to the shift register or something else. Nope. That's weird. Oh, that's just how they drew this. I get it now. Okay. I have a feeling this is a Steve Wozniak thing. I don't remember if this is the same circuit out of the Apple II. A0, where did you go? Where did you go now? Where did you go? And then probably 1. And then A2. And then A9. A 9, a 9, a 9, a 9, a 9. Uh-oh, there you are. You tried to hide from me, but it didn't work. Dun 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 dun. 13 and then chip enable. So what are we missing here? Let's do something like this. So we're going to hide the, we'll just put the no connect here. I don't really like hiding them. And then let's move this over 1. What is 25? A8. Oh, I missed one. Bummer. El Bummero. Okay, so we want to do a left to right so that we don't select the symbol. And then I'm just going to move these all up so that I can slot this into place. That doesn't look like the right length. Let's do ×2. And now that looks correct. More correction. And then we can move all these down. Oh, look at that. That's so pretty. Oh, good point, RJ Helms. Maybe the address lines of the chip don't actually match up to the address lines that are connected to it. So like this is probably not connected to actual address A3, or this is not connected to actual address A10 of the computer bus because the ROM doesn't care. as long as the computer knows how the ROM is organized, it can address it however it wants. We've talked about that before. Same thing with RAM. Given the external Pullups. Good point. Why would you need Pullups if the chip didn't float? That is I missed that one. Good. Hey, Ito. All right. So we're going to pull the same trick we did a minute ago. I'm going to Control X this. We're going to go to Sublime, or you may use whatever text editor you like. And we're going to change input to TriState, replace all. And then we're going to paste these back in. And again, this is something you can do through like the symbol table editor. It just takes like 2 or 3 clicks per thing. So I just do it in text editor instead, because that's what I like better. Okay. I feel like we're still missing something here. Oh, interesting. This has 26 as not connected, and we have 26 in this schematic as going to VCC. So I'm just going to do what the schematic has, because again, I was looking at an erasable EEPROM. I was looking at an erasable EEPROM that goes inside of this ATM machine. And so it's possible that on a masked ROM, this is something that you do want connected. So we're just going to do one of these, and I'm actually going to name it nothing. VCC times 2. Nice. Please apply 10 volts. Oh, that was a good one. That was so good. Okay, that looks almost centered. Is this symbol centered? It is. That way. That is not centered though. I'm going to move this over. Oh, that's what's going on. You're too far over. There. That's still not right. Okay, that looks better. That looks reasonable. Okay. So then what I was going to do is we can bring this. Let's see. If I bring this to about there. I don't like that to overlap. So we can bring this up quite a bit. And I'll leave that roughly near the bottom, because that will probably line up pretty well. All right. So we'll put that to there. We'll take this to there, this to here, and then where's this guy? Oh, oops. Okay, so this middle line is here right under the D2. So then I can just hit M, and I'm gonna just keep pressing this until there. And then I'll click on the symbol. So this middle is on the center and that middle is on the center. So this is roughly centered. And then let's go double check. So then we're gonna say character for Apple IIc. I'm just going to call it 2760. Well, I'm going to leave it named what they named it, just because that's what they named it in the schematic. I still don't quite understand how it can be both. I don't think it can. Yeah, actually, I don't understand. Oh, that's a good point, RJ Helms. And, you know, I wonder if, like, the original Apple IIs, if they actually shipped with EEPROMs. Because that feels like something they would have done. Run 2 traces and get the same result. Yeah. Okay, so these are TriState. I'm going to call those inputs. This is power. That's power. That's an input. This is an input. All right, we should be good to go. And those are TriState. Let's run the symbol checker. I don't know what that's saying. Prefix ending by blah, 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 blah can create issues if saved to the symbol library. All right. Does it just want me to say U? Is that what it wants? Okay. So it didn't like the U having the question mark. Okay, whatever. Okay, so we're going to go to here now. Now I'm going to right click, update symbol, and I should just be able to do update. Oh no, symbol not found. Oh, because I think I changed the name. Yep. All right, update, close, ta-da. Oh, that is so pretty. That is not the right symbol. What? Change symbol. Selected symbol, new symbol name. I want this one. Change. Did I forget to click change? Maybe I didn't click change. I bet I didn't click change. All right, so we're going to do the same thing they did. We're just going to put this stuff inside of here for maximum confusedness. No. And this is UE4. Okay. One more time. No. Man, I don't like how unaligned everything is. That's not acceptable. Okay. Now why are, oh, that's still not right. So let's go back to the library editor. I forgot to move this down. The circle's supposed to be outside of the symbol. Let's save that, and then we can go back to schematic, right click, update, close. Ta-da.
There was much rejoicing.
Yay. Okay. So now we need a resistor pack. Ugh, I hate resistor packs. What did I use on the previous one? Because that worked pretty well. So let's see. Oh, I know what I did. We can't use that one. That's not the one I want. Okay. Brr. It's going to be rough. Hello, computer. There we go. So let's go device. And then scroll down to resistors. I would do I guess I could have just done R network as a filter. Okay, so how many do we want? We want 1, 2, 3, 4. Oh my God, am I really going to count this? Wait, actually I do need to. It's not 8. Okay, maybe it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I would have said 8 and been wrong. So this looks like the correct one. This looks like the symbol I want. So we're going to plop this into here. Now, right, because it's the common is on pin 1, and then these are the things we're going to go into. So now what I'm going to do is I'm going to edit this. I'm going to do edit symbol, which brings us into the symbol editor for, well, it's the same symbol editor, but the scope is the schematic. But I don't want to do that. I want this to be in the library, mostly because I don't want E or C to complain, because E or C is a jerk. So we're going to say save as, and we're going to call this R network video, and I'm going to put that into the 2C schematic symbols. And then let's edit this information like this. We don't need that. We're not going to have the footprint. I'm going to actually call this RP. And then 9 network star bus small symbols. All the rest of the stuff I don't really care. Okay. And then I did all that because now I want to go into my pin table, and we want to make the pins go 5, 8, 9, 10, 7, 6, whoops, 6, 4, 3, and 2. Don't mean to add a new one. So then we get 5, 8, 9, 10, 7, 6, 4, 3, 2. I don't like how those numbers look, though. All right, so let's go into the Sublime, because I want to change length on this to be 2.54. All right, we'll cut that back out, paste these back in. Yeah, that looks a little cleaner. And it's because of this 10 was just smushing everything up. But I like that better. Okay. Cool. So then we can minimize this, come back into here. We'll do, I'm just going to delete this because I think change symbol is more confusing. If you're not the person who I've had an email with in the past, then I apologize, and you can reach out and I'll undo that. But I recognize your name as somebody that said something very similar to me once. And yeah. And so it occurs to me now that maybe I have you confused with someone else. So. Okay. Yeah, I think I owe you an apology. I thought I recognized you from something else. My bad. All right. Hey, Casper. Great to see you. Okay. So, item number next. 74. LS blah 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 blah. 14, 12, 11, 10, 5, 4, 3, 2, 1. No, that is, the enable is in a different spot. I think we can get away with just using, almost could get away with just using this one. So close. Why does this have, yeah, okay, I'll have to edit it. All right, fine. Oh my God, why aren't you loading? Oh, you know what it is? It's just not coming. Yeah, that's what's going on. That's stupid. Let me close this. Edit symbol. There we go. Let's do file save as. 2C schematic symbols. We're going to name this the SPI. I don't know why it's called that, but it is, so we'll go with it. And delete that. Okay, so what we want to do is move pin 15 over here. And pin 6 over here. Oh yeah, I don't like this. Now I understand what they did. They have the, I'll bet they have the power on a different symbol. No, they don't. They don't have the power pins. I don't like that. Find it kind of annoying. Okay. Yeah, Louise, I owe you a quick apology. Well, maybe not quick, but I'll quickly apologize. I think I recognize your name from something else. Maybe you've reached out to me before. But I had somebody in Brazil who had duplicated most of the content on my channel and then said I was being unfair because I don't want. It was a very frustrating situation. So, but I think I got confused because I feel like maybe we've interacted on somewhere else or something, because your name looks really familiar to me. So. I realize, and here's the, I'll be very open. Here's the thing that sort of, it's actually one of the reasons why I stopped doing tutorial videos. I've had a ridiculous amount of students tell me how they got a USB drive from their teacher with my videos on them and were told to watch them as part of their class. And while I understand why the students are trying, I get where they're coming from and why that's kind of it's cool and a reason to interact with me sort of thing. It is frustrating to me because there's a couple of problems. The first one is you're teaching students that it's okay to steal content, which, and again, I'm not talking to you, but I'm saying this is why I reacted, because I thought you were somebody that I had this very long exchange about. And it's like, that is, you're teaching your students that it's okay to steal content, which is not cool. And while it's not a lot of money, by downloading the content and giving it to somebody to tell them to watch on their own, now I get no revenue out of it whatsoever. And so that, it's, I sort of get it doesn't bother me as much where there are professors that are literally just creating playlists and telling their students to go watch them. It's like, okay, I kind of get that, but at least that sort of works in the whole grand scheme of things. But I have a ridiculous amount of people who tell me, oh yeah, my teacher, they just have us watch your videos in our class or something like that. And it's like, okay, well, first, it's like, okay, you're paying money to take a class to watch stuff that I made and I had nothing to do with it. That's a little weird. So anyway, that's also why I stopped doing a lot of tutorial content, because I was tired of being a free teacher. And the reason is, this may be not obvious to some people, but after, I don't know, the 100th or so email asking basic questions because, quote, my teacher doesn't teach us anything, you just kind of get tired of it after a while. So anyway. Is pen 9, I don't know. Let me get the symbol back. Well, and I really feel like these days it's even more important because it's so easy to, I guess even when I was in school, teachers did the same thing, because pen 9. I'm not sure what you're saying about pen 9. Oh, yeah. Unless there's another part. But I guess now I think about it, even when I was in school, teachers did, like, they would like photocopy stuff and just give us photocopies of whatever. And I guess that's about the same thing. And I don't know. It just, the thing that bugs me is, in like this particular situation that triggered me was, so that's saying S5. That's what you're asking. I don't know what the heck that is. Oh, you know what that is? I bet that's SS for ground. No. SS would be source. That would be 5 volts. But I think what bothers me about teacher stealing content, like especially like stuff from YouTube, is every single time I've struck down somebody's videos, they always come back to me and say, well, you know, I don't have a lot of budget, or blah blah blah, or whatever. It's like, okay, well, I can understand all of that. However, you didn't even have the courtesy to reach out. And it's not hard to find my email address, especially if you, I put it on the older videos and you can get it from YouTube. And so what just irritates me is oh, well, I didn't know, or it's like, you know, I appreciate that you're sorry, but if you had at least reached out and said, you know, maybe I would be understanding. Maybe there is a case where it makes sense. You know, there could be a possibility. But the fact that you're a teacher and you're not even setting an example. I feel like if I was a teacher and I did the same thing, I would say, yeah, and then go watch these videos, which, by the way, I have permission to share with you, right? I don't think it's that hard. But I've only ever had one teacher reach out to me, and in the email they said, we would like permission to use your material in a course that we sell to people. I was like, okay, well, how much are we talking? It was like, oh, no, we just need your permission to sell it. It's like, no. And you know, yeah, I think it's S5 as well. Your teachers did create all their own. And that's the other thing too, is it wouldn't be as frustrating. So actually my nephew was actually he sent me a text message with a picture of one of my videos. He was in a class being shown one of my videos. But in that case, it was, still, I would prefer if the teacher had said, hey, I'm going to show this to my class. And in that case, I didn't get so upset because at least he was showing it on YouTube. But still, at the same time, I'm like, are you serious? You're going to a college class and they're showing you YouTube videos. Like, get your money back, buddy. That's ridiculous. But, you know, anyway. I have no idea what S5 is. So what we're going to do is we're going to add a +5 for the moment. Same thing. I'm going to edit its symbol. We're going to save as S5 into the 2C library. Offhand, I don't recognize what this is. Now we do have to change it. I feel like there's somewhere else I have to change it. Like, I think I did this before, and maybe it was just, wait, what is this? Oh, the pin, that's what it is. Okay, there we go. Now I can add an S5. Yeah, and yeah, Balika. It was. I thought it was funny that they were reaching out, because I'll just say it's from a country that normally doesn't reach out before they steal stuff from you, and so that's part of what made it so comical to me. But I mean, I'm not really sure what the point of the email was, because it was pretty clear to me they were going to sell it anyway. Like, I almost wonder if the idea was I was going to respond and say, yeah, that'd be fine. And they're like, okay, well, can you send us? Because it is kind of hard to get the HD versions of videos with audio from YouTube. It's a two-step process for some reason. Anyway, that was a fun topic. Let's move on. Okay, 2 goes where? That goes out to ready. So you know what we're gonna do? We're just gonna go right for ready, because I don't want to drag that out. Hierarchy label, RDY, and it is an output. Let's put it there. There we go. That's looking good. How about those electrons? Yeah. Start up another rant. we should start like a rant jar or something. Okay. Well, you know what? If we're already kind of filling some of these other things in, let's get this other stuff done too. Let's do the easy things. All right, now for those that aren't familiar with this, you might notice that my VCC or my +5 volt is showing up as red instead of green. And then you might notice if I draw my ground down here, it won't be green either. It's black. Ooh, look at that witchcraft. Oh my God, that's driving me crazy. So I think it's new in 7, although I saw something in the Discord that made me think that maybe you could do some of this in 6, but I just never saw it. But you can define net classes in the schematic now. And so I defined ground in +5 volts, and then I defined main data 7, because that's a very special signal in the Apple II. I mean, any 6502. And then I assigned those net classes. So you create the net class, you give it a color, and then you assign the nets to those net classes. So like D7, ground, 5 volts. Those are the net classes. The net classes are up here, and then here's the colors. And so because of that, now my ground and VCC stuff, oh, it's still off. Okay, I don't care anymore, are different colors. Isn't that great? I think it's awesome. Okay. So then these three signals are all off-page signals. So first I want to make sure I have these in the right order, and then we're just going to create the, come on, unselect. Why are you, oh my God. Why did that open so many times? That can't be right. There we go. Okay. And then where did my other thing go? That's not the thing I want. I want this other thing. There we go. That's the thing. Okay, so we got pin 15. This is for the thing over here. So we got 15, 6, and 7. Oh, see, they made it longer. I wonder if I should do the same thing. That's a little fancier. Or, because I do like the idea. Okay, yeah, we're just going to kind of do what they did, because I do like the idea. So I'm going to come around here, and then we're just going to go like this. I didn't do this with ready just because I didn't feel like drawing all the way to the side yet. But even though it's not really necessary, I do like putting the off-page symbols or the off-sheet symbols or hierarchical signals. I do like the idea of having them on the edge of the page. So that's an input to here. And then this is vid 7M, and that is also an input. And this is 14 megahertz clock. The big time clock. Big. All right. So we'll do all that jazz. And then chip enable is the window signal. Haha, I recognize that one. Okay, so actually all of these, okay, cool. So what I'm going to do now is put the correct cursor back on. Turned it off so I could take some screenshots earlier. And we're going to start here, and we're just going to make, oh, you didn't draw the wire, did you? I'm going to do this up here for reasons which will be super obvious in just a moment. And now I'm going to hit insert a bunch of times and delete that one. Okay, so starting from the bottom, we know that we need window, and it's an input. And then we need language switch. I wonder what that does. Graphics mode. That's not readable. It's RA blob. I wonder if that's RA 15. 13 maybe? Okay, so let's go see. This comes from page 1, which should be up here. Oh, good. All the RAs come off of this one. But that's weird because I thought there was only 7 RA signals. So how can that be like a 1-0? Oh, here we are. What's up here? There's a RA 14 somewhere. Where did you come from? How did you become into... wait, how do you exist? RA 14. I guess I could go look at my own schematic. It would be a lot easier to follow. Is not connected to anything. But it doesn't go off page either. Okay. Oh, here we are. Oh, good. I can't read this one either. But I wonder if we figured it out from the 2E schematic. RA question mark. Yeah, shut up about the ground symbol being offset. So I don't know if you guys ever watched this guy, Ryan George. He does a series called Pitch Meeting. It used to be on Screen Junkies, and then he moved it to his own channel. His actual characters are the inspiration for the intern, even though I'm nowhere near as talented as he is. But that's where I got the idea to have somebody to talk to, and the person that I talk to is myself. But one of my favorite gags is the person will say, "Hey, what about this?" And then the lackey will say, "Hey, shut up about that," and then just keeps going. I just think it's funny. Okay, so somehow we determined that was RA10. So I think we figured this out from the 2E schematic, which is actually legible, versus this one, which is garbage. So we'll go RA10. That should be fun. No. All right. And then we'll come down here, put this back over here. But if you ever watch his videos, you'll notice, or you'll catch that in some streams, especially when I'm sort of thinking without, or I'm talking without thinking, I'll not often, but I sometimes say, "This is super easy. It's barely an inconvenience." That's his main catchphrase. But it works really well sometimes. It's like, how hard is it going to be for us to do this? It's like, oh wait, that was super easy. It was barely an inconvenience. Okay, so this is where this paradigm broke, because those signals do not come from the same place. Whoops. Very well then. We'll just do a quick reset. Okay, so where does those signals come from? Oh, they come from the latches. I think we'll wait on that because I haven't done the latches yet, and that's going to be kind of messy. So let's keep going this direction. We'll just finish this bottom, and then we'll worry about the top. What's down here? Ooh, there's a voltage regulator down here. I wonder what it's doing. "12 volts in." Wait, what is this? Is this seriously the power switches on this page? That doesn't sound right. Huh. Also, it's supposed to be 15 volts in, but okay. There's only one power supply in the 2C, and it's a 15-volt supply. However, I suspect it was designed to run from 12 to 20 volts because I think it was intended to be battery powered, which is why I think there's only one DC supply that comes in. That's what this appears to be. Well, that's at least the switch for it. I just don't understand, why is the switch on this page? That's suspicious to me. I don't remember. I guess maybe the power switch is in the back near the video connector, and maybe that's why. Anyway. We need a hybrid, so let's go draw that. You think people have successfully run? So, I don't know. I've talked about it for so long now. Maybe somebody's finally done it. I was actually thinking about making an adapter that plugs into the back of the 2C that then does USB power delivery, so that you could use a USB-C power supply. Because I think 15 volts is one of the voltages you can request, but I know 12 is. And so I thought it'd be kind of cool to have like an adapter that you basically plug your USB-C adapter into and then plug that into the 2C, and now you have a basically virtual or a virtual, not virtual, universal power supply. So okay, we're just going to go create this as a new symbol. Is it USB-C based? Yeah, I figured. I'm not totally surprised that somebody might have already figured it out. Like I said, I've been talking about doing it for so long that I'd be surprised. And not trying to say that they got the idea from me. I'm just saying it took me forever. Or I thought of it and then never did anything with it. Well, not entirely true. I did buy some parts thinking I was going to build it. And then I never did. All right, so this is going to be U. And we're going to call this vid. Hybrid for video signal generation. Yep, I'll be darned. Oh, wow. February 16th. Of course. Of course. That's even better. Yeah, no, more or less the idea that I had. Yeah, that's what I was thinking. Oh, and they're powering off of a USB power bank too. That's even better. That's awesome. But how are they? Okay, so this cable has a chip to negotiate 12 volts. But okay, neat. I don't know that I would actually trust that one just based on the fact that it's sold as a 20 volt cable and only 12 comes out. My concern there would be is, however, the negotiating power delivery may not be correct, and so that particular person's getting lucky with it. But that's the same concept of what I had in mind, is something along those lines. I would at least want to do some more testing on it before I trusted it. All right, we're going to make this passive. You know, we're going to do 2 because this is, I really like, okay, yeah, let's come into the table and just do 1, number 1, name nothing, and we're going to make these all passive. And see, number 2, nothing, number 3, nothing, number 4, nothing, number 5, nothing, number 6, ground. I'll rename it in a minute, or retype it in a minute. 7 will be -5 volts. Number 8 is nothing. Number 9 will be nothing. And number 10 will be +5 volts. And then we'll make this a power input. Power input. Power input. Okay. So now we will take number 10. We're just going to move it up here. Why are these all coming out with 2.54 millimeter for their pin lengths? That is getting slightly frustrating. I don't like that. No, sir. Actually, maybe 2.54 is okay, but I think I still like them to be longer than that. You know what? Maybe we'll leave them. Why not? There's no labels on them. Okay, so 1, and then 2, and then 3, and then 4. Did I forget 5? Oh, I have 2 4s. That's why. 1, 2, 3, 4, 5. And then 4 can come over here. 7 will rotate. Ground will rotate. 8 we will put somewhere over here. And 9 goes way up here. Up where the air is clear. Doot, 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 doot. All right. Okay, now we'll draw some form of box, which we'll have to modify, but we'll get to that. And just trying to eyeball what they did. We're going to make ours a little bit long. All right. I think we're still going to go slightly longer. I have a feeling it's going to be worth it. Okay. Now, we will 2 things. First, let's fill this with a background color. There's a, I'm calling it a bug, even though it's probably not actually a bug. But if you tell KiCad to fill with a custom color, it covers up anything that's inside the symbol, which is unfortunate because like I would actually prefer to make this something other than yellow, but alas, you cannot. All right. Okay. That centers that. And then where's this one at? Right about where the 2 is. Okay. So let's put that there. Click on this. Yep. Neatly centered. Okay. And then I already filled out the stuff. Oh, its name currently is U, which is what? Oh, yeah. Symbol name. Vid. There we go. All right. I should close that. Now we can come back to here and say add. No, where'd you go? Come back, come back, come back, come back. What is going on? Add vid. There we go. There is our hybrid, which is going to connect to 13 somehow. And then 2, 3, and 4 are coming off the page. They come around the ground of that. Okay, so here's what we're going to try. See if we can keep this lined up. So 1, 2, 3, right here. All right. And then let's see, I wonder which one this is. It's probably this one. Okay. Just went to verify. Yep. So that should go to pin 2. So we're going to move this down a little bit. This is where we could modify the symbols a little bit. You know what? I think I disabled a critical feature because I was trying to answer a Reddit question that kind of frustrated me. Yeah, I think that's causing me to have, there we go. Somebody was asking how they had just moved from version 5 to version 6, which I still think is interesting just because it's like, why does anyone still have 5? But that's not the point of the story. So they wanted to try to get back the hover over something and press the hotkey behavior. So like, for example, it used to be if you were hovering over this symbol, or you clicked on this symbol, and then I came over here and hovered over this label and hit E, E would actually now select that part and open its properties. But ever since version 6, that went away. And somebody's getting upvoted for saying, oh, you can change that. It's in the preferences somewhere. And I just find that really interesting because no, it's not. That's not an option. And if it is an option, I would very much like to know where it's at. But I just think it's funny where somebody's just like, oh yeah, that's an option. It's somewhere. It's like, well, could you maybe, I don't know, say what it is? Because I can't find it. In fact, hey, Lorenzo, thanks for coming by. Have a good dinner. If I don't catch you on Discord this week, hope I see you next week. All right. Okay. And then we need a -5. -5, -5. Why so negative? All right. And then up here, we'll have a +5, which I should be able to just copy from over here. There we go. Setting an eagle that keeps the IC from showing ground and VCC on the ICs in the schematic. I don't know how eagle does it. In KiCad, they get they either are hidden, which is frustrating because VCC has to be the same then, or that's a terrible explanation, but it's just frustrating sometimes. Or they're a separate separate unit, and then you have to add the unit. But I don't remember how Eagle does it. All right. This is going to be 1. I guess 1U8. I don't want to use decimals. So yeah, I guess it's 1U8 for that. That's weird. That just feels weird. And then we're going to have NTSC come out of here somewhere. So let's go ahead and just draw that. Come on. Draw that line. And add a hierarchy for NTSC, which will be an output. And then let's go ahead and add vid out, because that's basically ready. Once we add a capacitor, I would like more separation on this. So we'll go into the symbol, and I'm going to move 9 up here, which probably means I need to move 1 up here too. And then we'll move these at least down there, because I think they're supposed to be in line with that. Yeah, okay. All right, close this, right click, update, update, update. I just got flashbacks to Friends. Pivot, pivot, pivot. What did you want me to do again? Pivot? All right. Okay. So then these have to move down to here, and then ground will go right into here, and we're just going to turn ground off because it's kind of not point. There's no point in showing it. And then this is going to become C65, and it is 330 picofarads, or puff. That's another good name for it. So what's a variable inductor called? There's no small trim. Okay. That's unfortunate. I mean, it's not a big deal. It's just I would have preferred it. All right, so this will be 2. Oh, good, and there's no value on this. That's even better. All right. Now, I feel like I'm missing a couple of things. So, Sir out, my favorite signal ever. That's how we're generating video on the Mega 2 project. Oh, man, this is going to break everything. Oh, what I should have done. I didn't realize what a pain this was going to be. Okay. So then this needs to move down. All right. And then this will come out here. This will move down. All of this can move down to here. And then we can move this over to there. There we go. Let's center that so it's a little nicer looking. Okay, now I got to play cleanup over here. So a W and connect, delete that segment. W and connect, delete that segment. W and connect, delete that segment. Okay. I still have Sir out necessary from somewhere. So we're going to grab that from here, click once, and then bring this over. And then do like this, go copy paste here, and we're going to call this not Sir out. Although the Mega calls it Sir vid, but that's okay. Same idea. Same idea. Okay, so then what we can do is let's move all of this up like this far so that we can grab this, hit G, and move this all the way out here. And then this lines up just like this schematic does, which does look pretty good. I like that. Oh yeah, that's some good looking stuff right there. Are those all lined up? They are. Oh yeah, fun times. Okay, so what do we want to do next? Oh, I need to name these signals over here still. Okay. Oh, they didn't line up exactly. Oops. Oops, oops, oops. Okay, okay, okay. That's cool, that's cool. What we can do, though, is I'm just going to grab these 3, and we're going to move them up anyway. And then that gives us a little bit of a gap. That works out. So I like the way these are grouped. They're grouped like this on purpose. Okay, so next we need not sync. So this is the pulse to tell it is the, which way is this? The horizontal sync pulse. And then cref is 3.518 megahertz. So that's our color burst information. And then color gate determines whether that gets added to the vertical line as it's getting drawn, which is how we control whether or not we get color on the Apple II. Neat. Okay. I do think we're going to move these up a little bit as well, since we can. So we'll do a G, bring this up to about there. But keep them separated, sort of. Okay, yeah, I'm liking that. That looks good. Okay, so then, let's see. These things look like fun. Should we go ahead and just knock this stuff out? I think so. There's only a handful of things here. Tell you what, I'm going to take a quick break. I need to fill my tea back up and use the restroom. So I'll be back in just a minute, and we'll keep going. So I'll play a fun clips reel. All right, get ready for music. I don't know what the volume, if the volume is going to be different. So thanks. Actually, let me just do this. All right. Okay. I'll be back in just a minute.
Previously on The Bald Engineer.
Shoot. I did the wrong thing. One day, I'm going to learn how to use Twitch. Stay together and kiss. It's just weird how they're just like, nope, 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 nope. Okay. I'm happy there. I'll stay there. No problem. Oh. What? Oh, that was not good. It's the tab. I think tab is ground. Not, it's maybe Yep, fell right for that one. Yep. There's no solder mask. Yeah, that's why. Smoke, 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 wick, 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 in the Mario land of Bald Engineer basement studio. You go plop, 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 and you go smoosh. 99 solder joints to go. 99 solder joints. Melt the solder, flow the... wick the solder up the post. 98 solder joints to go. This is why I don't make songs for a living. That bald pig in place goes brrr, 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 boy. Oh God, wait a minute, what? No. Oh, no, yeah, okay.
And there was much rejoicing. Yay!
And then turn on the modem. Oh my God. So that works.
And there was much rejoicing. Yay!
Where did my magic blue tape go? I can't have a stream without blue masking tape. That's just ridiculous. So those watching on YouTube, if you didn't know, I had been streaming on Twitch for the last couple of years. That's some of the stuff you might have missed. And even if you're from Twitch, you might have missed some of that too. Although that's the older reel. Anyway, all right, our friend Ito has pointed out one of my mistakes. So let's go and fix that. Yeah, everything on here is an input. Input. Okay. That is fixed. So what do we got next? Let's see. We've got a diode, a cap, a fuse. Okay, let's just throw these parts onto the schematic and then we'll go from there. So let's do a D small. I like the small version. And we'll put it upside down. And then let's do a C small, very small. Basically, I am very small. And then an F. How about fuse small? Okay. Now, yeah, let's kind of just fill these in now. So this is CR1. And it is a, oh goodness. What is a 1 in 5 4 8. Is that a diode? There's a 5408. What if it's just a 5400? Oh, yeah. Yeah. There's a bunch of these. Okay, that's got to be what it is. And what is it? It's, wait. No. Glass, passivated, standard. Okay. Yeah. Okay. I bet that's what it is. 5400. Okay. And then this is C59. And it is point. I wonder. So is it 100 picofarads or is it 100 nanofarads? Because it's just 0.1. Well, this says 1,000. This says 35, which makes no sense. Or is that a 38? That doesn't make sense either. Let's see, is there any other caps on this board? Probably not, because all the decouplers are somewhere else. So I'm going to guess it's 0.1 microfarads, so I'm going to go with 100 nano. I don't like decimal points in schematics, partially because this reason. These got printed, scanned, and some of the decimal points are messed up, so I don't like to keep it. Yeah, you guess it's okay. We get 1 vote for microfarad. We're going to go with microfarad. And then this is probably a 10 amp fuse, which gives me more confidence because this blob looks a lot like those two blobs. And so 10 amp fuse sounds reasonable. All right, now we can move this stuff over a little bit. I think these are all in line. They are and are. All right, now let's add an L pack, which I think we already have made. Darn it. Although, wait. Oh, you know what I'm thinking of? I'm thinking of the 2GS. Or I'm thinking of the, whoa, I just lost my mind. The Game Gear. Because I swear, I just made an L pack the other day. And I'll bet it was in the Game Gear. Okay, so let's go. And that's why I'm just going to copy it from there because I just recently did it. So let's go to the symbol editor. I think I want to come into the Apple IIc symbols. I want to import symbol. I don't think that actually works. I think if I try to do import symbol, it just imports the first symbol in the library. Because I think I tried this the other day. Yep. I don't understand what the point of that import symbol is. So what you have to do instead, the only way I could figure this out is I can add the library. Waiting. You can still see the dot. Yes. That's not the best example because you can see it there, but in some places you cannot see it. Okay, in here, you know what? It wasn't even in this one, was it? Yeah, line filter 3 element. So we're going to save as. Yeah, I'll just keep it there. And then we're going to save this into our 2C library. Save that. And then I'm going to take this library out because I don't want it in my project. I mean, I actually want to be careful about complaining because I'm always so careful about complaining. But I'm so grateful that companies back in the day published their schematics. Like, you know, it's nice that they actually published them. All right, this is not going to be confusing at all. So this needs to be, I need pin 6 to be 1, pin 5 to be 2, 4 to be 3, 4, 5, 6. Did I get that right? Do I win? 1, 2, 3, 4, 5, 6. Ooh, although I just now realized why that was a lot easier than I made it out to be. I'm just going to say... Okay, save that. Save, close this. Come back into here, right click. Nope, we'll do add. And then we'll do line, filter, 3 element. We'll place that here. And that's all we need to really do there. That's pretty snazzy. I'm quite happy with that. All right, so of course they had to have a custom 12 volt symbol. So we'll do 12 volt and then I'll click this and we're going to edit this. I'm going to do edit symbol. We're going to do file, save as, 12 volt VN. We'll add that to the 2C library. And then we will change its name, 12 volt, 12 volt, 12 volt in. All right. And then we change the pin name to 12 volt in. And then I would like to copy the style they have. So, come to think of it, I don't know how to do this. Like, I don't know how to fill this in. I wonder how the other symbols do it. Let me try something real quick. Can we just draw a polygon? Ah. And fill it? Oh, okay. So then if I want a filled in rectangle, that's not a rectangle. I want a filled in rectangle. Oh boy. Filled in rectangle. Outline color. There we go. There we go. Cool. That's not so hard. Who publishes company secrets these days? Well, you know what really blows me away? Actually, okay, well, I can't talk about that. But what really blows me away is like two things. I think I have both documents open, so this won't take long. Yeah. So this schematic was available. I'm not sure where this one came from, because this one actually looks like it was actually the original schematic, which is not normally what we get. But like, for example, usually in the technical reference manuals, which is like what this is, what am I page on? 471, just to point it out. I mean, this was like the actual Apple manual. It wasn't like a third-party thing. They have the schematics in here, and then they have the full firmware. And so this is the part that kind of blows me away, because not only, I mean, this is the one thing that I think even if you dump the ROM, it would take a considerable effort to deconstruct it. Like, yeah. However, you could dump the ROM and then use this to reconstruct their entire ROM. And that just blows me away that somebody was like, hey, this is a good idea. And I mean, thankfully they did, because that's what enabled the computer to do so much stuff that it ended up doing. But it's just kind of like, wow, that's just. And they weren't the only ones at the time either. I mean, Commodore did the same thing. I don't know how open Atari was with their computer stuff. I just haven't looked at their manuals yet. I haven't quite gotten into the Atari computers. I found all of mine. I have at least 2. I might have 3. Well, actually, I have the Palm Top computer that the kid in Terminator 2 used to open up the vault. So I at least have that much. And then I've got like a 800, I think, and I have an XE and maybe like a 1200 or something. The Atari, all of the Ataris I bought at the electronics flea market years ago when I lived in California. So that's why I don't remember what I have, because I basically bought them and then just never looked at them again. All right, we're gonna do that symbol because I like the rake. Okay, so then line 1 looks a lot like this. Publishing, it's a good way to protect your copyright. Oh, that's a good point, because if you publish the book, then you say, well, this code is copyrighted. So then if you can dump somebody else's ROM and prove that they used your code, I didn't think about that. Yeah, actually, RJ Helms. If you remember what you read that in, I would like to know, because I would like to read the book. I only knew about that from the Gaming Historian. He had talked about that. Now I think about it, maybe I have read a book that came from. Is the Atari 400 the one that has the membrane keyboard? Isn't that like the difference between the 800 and 400? Is there's like a little bit of RAM difference, and then the I think the 400 has the unusable keyboard. All right, and then where's this 10 amp? Where's this fuse going? It goes to E. Okay. I'm not sure how I feel about these names, but or that comes from E. All right, and then I'm guessing this is where C and D are. So line 5 and line 3 are C and D. Okay. So let's just do this for the moment. Okay. And I'm just going to pop these in here, and then we'll go and check to see what they're supposed to be. So this is supposed to be C. This is D. And then F. Where is F? Okay, F we haven't gotten to yet. Wait, it goes F, C, D. Okay. All right, and that's going to come over here somewhere. And then just so that I don't have to keep going back and looking at it, I'm going to just label this here so we know what it is. Yeah, 1 slot versus the 2. Yeah. Is it the E, the dolphin pin? Nice. Yeah, and and like the RAM was different. Like, I know there's a couple of other technical differences, but I think it's like the same basic computer, right? And then just a handful of differences. Okay, so 12 volt in is also going to be over here. And we also need a capacitor. So although that I'm going to put a non-polarized symbol because that's what's in this schematic, but I'm pretty sure that this was if it's a 25 volt 1000 microfarad capacitor, it had to be an electrolytic. Like, you're not going to convince me that it wasn't. Like, I don't think that could have been a film cap. It sure as hell wasn't a ceramic. I mean, you can't even make that today. Okay. So what are we going to do about a switch? So what is this switch? Oh, this is, what is this? This is a single pole double throw? Yeah. All right. Man, if only. All right. And then that goes to here. Okay, let's move this up a little bit, because this is going to go over here. Let's move these down. Move that up. Move this over. Whoa, what'd you do that for? G no re. All right. And then this is going to connect to the ground. All right. And then let's see. This doesn't have this as a name. This is switch 1. And then we'll do a little bit of text. We'll go on. Now, does this look suspicious to anyone else? This says, this is labeled as on and off. Off connects to the 12 volt supply, and on connects to ground. I just don't feel like that could be, I don't know what the right word is, correct. It just doesn't feel right. The other thing is this signal. See, this is the suspicious thing, is FFF is an input to this page. We're going to go look at the other page because I don't trust this. But it comes in here. Why would this come as an input and then go to there? Okay, let's go look at the other page and see if we can understand what's going on. What's the other side of the signal? So it's on page 5. Oh, you know what I should have looked at too. So it's on page 5 and we're looking for J11. So J11 is the power supply. Here's the FFFF signal. Huh. What would, so all these power signals are labeled C, D, E, and F. Why would you call them that? The power jack, the jack for the input power is, so the power supply on the 2C, let me see if I can find a picture. It's a module. It's actually on the Mega 2E. This is where I got the idea. Oh, wait, I'm wrong. I thought the input power, okay, hold on. Because the power supply plugs into here, and that's what the J11 we're looking at is. I thought the jack was actually on the power supply, but it's not. It's on the motherboard, as is the power switch, switch 1. So this signal connects to the power supply. And then it looks like, okay, where is the power jack? What do they call the signals? That might give me a better clue. So the power comes in as A, B, C, D, and E. But none of those go to the power supply. So what they do is, instead of going, so they go from the DIN plug, or is that the jack? Whatever. The DIN input, C, D, E, and F. They come into this line filter and this fuse. So E comes in as a fuse into the 12 volt. And then C and E, or C and D, are basically ground. Yeah, so E comes into here, and that goes to the 12 volt signal, or the 12 volt input. But the only thing that comes, so then this 12 volt in and this 12 volt in are connected together. This is backward. This has to be backward. Because if these two connect, then 12 volts goes back into FFF. And that's the only way I can see that this power supply gets power. Although this says, this almost looks like 12FN, and there's a bunch of them. But then there's 12 volts down here. It doesn't make sense to me that you would switch in the power, switch in ground though. That doesn't, and it doesn't actually look that way. It's pretty clear that ground is D, C, D, what is it? It's C and D, which are grounded. And there's no regulator, as far as I'm aware of. There's no, wait, there is a 12 volt regulator on this board. I mean, the fact that this 12 volts comes in through this filter and this fuse really makes me think that EEE is the only way we get from the barrel jack into the 12 volt line. And this doesn't show the power. Well, this wouldn't show power though, would it? I wonder where else that 12. I don't know what that 12VFN. Here's 12FIN. Well, that's weird. Unless that's for the accessory port. Which connector is that? Because I could see that going to the LCD port maybe. No, it doesn't. I don't get why. So this 12 volts comes into this op amp and through this divider, which then go into this 555, and that's it. And then this 555 creates a signal called flash, which I'm wondering, is this the thing that flashes the cursor? Because in the other Apple IIs, no, that's not true. In the 2 and 2 Plus, there was a 555 that did the cursor flash. But I'm pretty sure in the 2E and the 2C, I thought it was the IOU that did it. Then again, maybe I'm confused because the Mega does it. But why would you need 12 volts for that? Where is the IWM? Oh, here's serial. Serial might need 12 volts. That's the UART. Where's the transceiver? Yeah, that just uses regular 12 volts though. Here, there's that S5 again. Really curious what that is. I don't think we have the power supply schematic. Hold on. Maybe I have seen the schematic now I think about it. Nope. This is the one I have now, which does not have the power supply. There's the pinout. Nope. Let's see if Henry has it. Nope. Yeah, it doesn't tell us anything. Okay. I welcome your guesses. I don't mean to dismiss them if I think they're wrong. Even if I think somebody guesses wrong, it still kind of sticks in my mind because I try to think, how could it be right? It's just sometimes it's kind of obvious. Yeah, I don't think anyone has the schematic. Well, I guess I could go get my power supply board and we could make one. Which maybe we'll do that. That might be a fun lab project. Okay. Tell you what. I don't want to spend any more time on this. I think one thing we could do is go get the real Apple IIc and just see how it's wired. And then that would tell us. So instead, what I'm going to do is just write a note that's curious. And then what I've been doing now that 7 supports fonts, I've been using, I don't know how to say it, Verdana. I just realized I actually pronounce this veranda, and that's not how it's spelled. So anyway, I've been trying to use a font different than like the KiCad font, because this is meant to indicate that, oh, this is a note. I do not have this Apple II book. No. I have the 2C, I have the 2C, the 2 Plus, the original Apple II reference, the Apple II Circuit by Gaylord, which is my favorite book ever. It explains everything. Its detail is sometimes a little too deep or obtuse, but it's got explanations of everything down to pin 7 of this register does this. And I mean, it's really good, but I don't have the 2C reference manuals. So I have a search set up on eBay to try and buy them, but I would rather put my money into gold sheets. Yeah, we're working on a 2C, and all I want is the what I'm missing is the power supply board. It's not in this schematic. I'm gonna double check just to make sure, but I'm pretty sure I've never. What's bothered me is I feel like I have seen the schematic for the power supply before, and that's why but I don't. I might not have, because that's connectors, that's I/O, that's I/O, that's video, and that's CPU. Yeah, they don't have the power supply in this document. I guess I could look at this one real quick. View, page, rotate. You know what? I don't care. If you find it, who's it? Merc. If you find it, let me know. I would be interested in it. I'm not going to spend any more time on that right now. Occam's razor. It doesn't mean what I think it means. I mean, either it's wrong or it means something different than what I think. And if it's wrong, I don't have enough reference to fix it. And if it means something else, I don't have enough reference to fix it at the moment. So we'll just move on. All right, 7905. Of course, they drew it different. So, come on. Really? 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 Okay, fine. I don't know why. I wonder what package it uses then. I wonder if it's actually a surface mount package. Huh. Okay. Save as. All right, we'll save that. Let's go into our thing. We'll get rid of this because that's annoying. We'll worry about the reference later. This is the symbol name. Will just be 7905. I'm going to take these off. 7905 for -5 volt into C. And for those that don't know this, so the 78XX is those are, like 7805. That's a 5 volt regulator. So 7 volts in, 5 volts out. And then the 7905 or 79XX are negative versions of the same numbers. So 7905 is a negative 5 volt regulator. However, you must give it a negative voltage going in. So it needs negative 12 volts to create negative 5. You can't put a positive voltage into it. Well, you can, but it won't do anything. All right. So let's go to the pin table. So VN on here is 1. Ground is 2 and out is 3. I feel like I'm going to look at something. I feel like that's the normal pinout. Huh. I guess not. Okay. So then we'll do a Y. No, we'll do an X, V in, ground, V out. I'm going to draw it just slightly different because I don't feel like redrawing this. There's no reason. And we'll rename this to UB13. By the way, I've talked about this before, but I'll actually show it now. So notice how all of the ICs on here are not named like U1, 2, 3, 4, 5. They're always a letter and a number. So this is UB13. If we go back to that 2C picture I had a minute ago, you'll notice along the right side of the board, there are numbers 1, 2, 3, 4, 5, 6, 7, blah, 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 right? There's number 13. And then along the bottom are letters A, B, C, D, E, F. So skip the U. So if we go to B, up and over 13. So 13 over, B down. So this chip here is the 7905. So that's how the two, and Apple did this. So in the Macintosh LC that I took apart, was they followed the same thing. And so since the Apple II, up into at least the Macintosh LC line, they've always arranged their boards this way with rows and columns, and then the schematic matches the row and column, which I think is really cool. Because like just like this, it's like it takes zero effort to figure out where this chip is at. So, okay. Okay, so VN is negative 12 volts. It's probably drawn upside down because it's all negative. I bet that's what they were doing. Huh. All right, we'll do it this way. I'm not sure that I'm a proponent of that, but I'm not going to make a big deal out of it. All right, I'm just going to put this here. Negative 5. Rotate, put that there. Then we're going to grab this, copy, paste, exit, or X to flip it, and reverse it. Bum, 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 bum. All right. Actually, what we're going to do is we're going to G and bring this over a bit so that we can add a C small. And I'll put it like right here. All right. Put this over here, and it is C60. And this is where I don't understand how, what number could they have possibly meant? So 35 is what it looks like, but that doesn't make sense. Oh, but we're not gonna be able to see the, wait, can we see the cap in here? Oh, that's it. I can see it. It's right there. Huh. I guess I could wait until I can go and look at. It'd be cool. It'd be a cool feature to rename it according to the coordinates. Yeah, actually, that would be really cool. That would actually be really, really cool if you could do that. So what I should have done on the Mega 2 board, well, maybe for version 4, I'll go back and create a Grid pattern. Yeah. I'm kidding. There's no way I might do a version 4, but I'm not doing that. That's for sure. Okay, let me think. Won't it be 35? Could it be 68? Or 36? 56? God, that looks so much like a 3. It looks like 35 to me. It can't be right, though. Apple service programs? Yeah, I mean, unless it has a schematic, I don't think it's going to be too helpful, just because, I mean, basically I need to know what the pinout of that edge. Well, that's not even true. I need to know where the signals are going from the edge of the power supply into its design. I just can't think of what would 3 and 5 be on an electrolytic capacitor. Like, it'd be 27? Or I don't think the E24 series has anything with a 3. There is a 36 or 39. Maybe it's a 9. I guess there's 33. I should have realized that. That just seems like such an odd, or I wonder if that's 30. No, I bet it's 30. Is 36 an option? It's got to be. I bet it's 36. What about E12? Where did that list go? Yeah, so E12 would be a 33 or a 39. Okay, I'm going to go with 39. Because it's not 35. I don't know. It doesn't matter. I spent way too much time on that one. I'm going to call it 39. Let's do that. There we go. All right. Let's add the voltage for posterity. V rated is 16 volts. Forgot to tell it to show that. And then we'll move that to be a more better place. All right, time to do this. Yeah, that's why I'm struggling, Ito. I can't imagine it's 35. That just doesn't. I just don't know why that value just doesn't make sense to me. So I feel like 6 or 9 are our only options, but it doesn't really matter. It's not like it's electrolytic C60, which is the only thing next to that chip. So it's not. Anyway, but I will look at my 2C board and see what it has. So, okay. It's just frustrating. It's like, I would rather know what it is and just have it done. Okay. So that, I think, covers this power supply section. That has multiple questions. I have 3 questions. Number 1. What is C60? Number 2, why is on and off seemingly backward? And number 3, why is the power switch on the video board? I don't understand. I guess it's all on the same board. Video section of the schematic. That's what I was trying to say. All right. So I think we can move up here and let's take a look at this and maybe we can do some batch stuff up here. So this is going to go RA0 all the way down. I think I'm going to do the same thing I did on the other bus because I don't like the way they did it, just because it doesn't work as well in the way with how KiCad works. So I am going to do the same trick I did the other day, and I'm going to change our grid to super chunky. I can't remember how I did this because I don't think that's chunky enough. Like I think I did like 2.54. And that doesn't even look chunky enough. Yeah, that's not going to work. Because I want 1, 2, 3, 4, 5. You know what I should do is if I go look at this sheet, what's the grid spacing on this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So place 1 and then go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So if I bring this over here and then I grab this one, I say, that's going to be a lot faster if I do it this way. Nope, it's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's actually not what I want either. I want it this. Okay, so then we can bring this and line that up, and then that lines up to there. Okay, so then we move this over to this grid number. Then we grab this and we go to here. That doesn't line up at all. There we go. There we go. There's something with the grid behavior, and I'm not sure I understand it yet. But it's like when you first pick the part up, it doesn't snap to the grid right away. But then the second time you handle it, it snaps into the grid. So it's almost like its default behavior is to stay on the original grid. Or not the grid. What am I trying to say? I don't know. It's just I'm noticing to hold things on a grid, you have to move it twice, which I think is weird. But not always, which is part of the weirdness. Okay. Those are not memory chips. No. Okay. Let's move these over here. And then let's delete this. And then we'll move this up to here. Oof. Out of space. Is this an A3? It is. Shoot. How did I do this? Oh, I just made it all on its own. That's why. Okay. Okay. Well, maybe we'll have enough space. Maybe I can just do it like that. Oh. I don't want to make this sheet bigger because I want all the sheets to be the same size because it makes much nicer PDF. Maybe we can get away with that. It's yeah, probably where it had space. It could make sense. Yeah, I'm not surprised that the external supply was only $25. I wouldn't be surprised if it was not even regulated. It might have even been just like a diode regulated power supply, because the internal supply was a relatively complex switching supply. So Yeah, Ito, I'm not sure. So Aaron, where are you getting? Are you talking about the data sheet for the 7905? I mean, I appreciate you looking at that, but that doesn't, I mean, I don't know that they would have followed the data sheet. And in fact, it looks like they didn't, because I don't think they have a decoupling cap on that one, or decoupling on cap on the input. But yeah, you know, what you described might be what's going on. I'm not following. I'm just not totally following what it's doing. So, okay, so now what we're going to try is if I go back to this grid, which is the grid that is, we'll call normal. If I did this right, we shouldn't have any trouble lining stuff up. And I'm just going to do a couple of wires real quick to make sure that things line up. They do. Okay. All right. Okay, so I'm going to put the RAM up there. And then we're going to, so these are labeled RA 0 through 7. They come off the bus. Okay, because this is how we did the main RAM. So I'm basically trying to duplicate the same thing. So first let's create, what am I trying to do? I want a label, and that's going to be RA0. I'm going to flip that around, and we'll put it roughly there. It doesn't really matter. And we'll do this to get it 7 times. And then I need to X to swap it to over there. And then I want to make a line that's going to be just long enough to pull it off. So we'll maybe do like this. And we'll use the insert key to get that a bunch of times. And then I'm going to use Q, not Q. I'm going to use Z to get the pick off the address bus. Okay. And then we're going to hit B to draw a bus up to about, I don't know, here. Because then what I'm hoping I can do, hope, copy, paste, and then we should be able to just slap this down next to each of these. See, in their schematic, they just drew lines all the way across, but the problem is I don't have a way in KiCad to kind of hide the lines going underneath, and it just makes it look super messy. So instead, we'll just make a bus and get it this way. All right, and then we can bring this all the way over and roughly line it up with these. Oh, no, we're not going to line those up. All right, so then we can have a hierarchy label that is RA 7.0, and I'm pretty sure this is input, because this is aux RAM. No problem. Hope you learned something. I've actually got a plan to get back to doing the KiCad quick tips videos, and I think I'm actually going to. My plan is to actually make short videos. So either YouTube Shorts, TikTok, Instagram, where the videos are only like the 2-minute tutorial. And then like I'll have 4 or 5 of those, which will become the YouTube video. Instead of making like 2-minute YouTube videos. Also, it's a pain in the butt. A lot of work to do that. But I had wanted to get back into it, and I guess it's been almost a year since I made one, so I should finally finish the one that I was working on. Okay, so, and then the rest I just did as labels. So, okay, let's do the data bus next. Let's get that done. All right, and then let's make sure that follows the same pattern. It does. So we're going to do, how did I do this before? I wonder, can I just copy like this whole block? And then, oh, I know what I could do. I know what I'm going to do. this is how I did it before. So I did these because this is basically just copy and paste. That's easy. So then we're going to do a label. I'm going to do Alt 0. Is it Alt? That's weird because I'm pretty sure it's supposed to be aux, but whatever. Alt 0, and then we need 7 of those. And I'm going to flip those upside down with Y. Yeah, okay. And then we're going to flip these the other direction with X because I'm going to put this one here. Move these over here. And then this one is going to go here. And this one is going to go here. And then we'll move these over here. Right? Yep. So this one's going to go here. And this one's going to go here. Then we can move these over to here. And this one goes to here. And this one goes to here. And then we'll move these over to here. And that should look good. So 0, 1, 2, 3, 4, 5, 6, and 7, right? 1, 2, 3, 4, 5, 6, and 7. And then we're just going to come here, hit B for bus, and come all the way over to here. And I don't know where we're going to end yet because I'm not sure where this goes. But I just want to get this drawn. Hello, I just want that. No, stop. Okay. Okay. And that's where like these latches come into play. Okay. Interesting. Maybe this isn't the aux bank. Yeah, it is. It's for, okay, yeah, it's for the 80 column card. Okay. Oh, and it's connected with the video stuff because I think that's on slot 3 in the 2E. I think. Push the Chat GPT routing button. Yeah, right. If only. I really dislike auto routers. I can't imagine how long it will be until an AI can viably route a schematic. Only because, well, I was going to say only because it's like writing, except AI is doing a pretty decent job with writing right now. So, I could be mistaken on that. Well, here's the thing. Now that I did all that, I could definitely scrunch up these memories and probably get enough room for the latches to be in line with them. It wouldn't be that difficult because all we got to do is, I think if I hit U, nope, that doesn't work. Huh. Oh, I should just be able to do this though. This should work. And then same thing up here. I already typed that. I don't want to type it again. But if I do this, okay. So I think what I'm going to do is let's go back to Chunky Grid. Let me save this first in case I totally change my mind. I'm going to go to, yeah, we'll just leave it at the Chunky Grid because I could actually go slightly chunkier actually. This will make it a little faster. Okay. So then if I grab this and just said move, oh, I don't want it to do that. Okay. We'll have to just deal with that. If I grab this and tell it to move, and then I go 1, 2, right? And then this, if I tell this to move, and then I go whoop, 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 all these and say, ooh, what I really want to do then, I think I want to grab all of these and say move and go 1, 2, 3, 4. And then grab all of these and say move 1, 2, and all of these and move 1, 2, and then all of these and move 1, 2, all of these and move 1, 2, move all these and move 1, 2. Okay, I like that. I like that a lot. So then let's get out of this grid before I make a mistake. Where'd it go? Where'd it go? Where'd it go? Where'd it go? Go, 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 go. Okay. Now, if I grab my bus, which looks like it should have been here. Hello. All right. Just kind of click that, get a nice anchor going. Yeah, that's fine. And then I'm just going to come to like right here for the moment. Let's move this guy over here. And then fix this up. You go there, you're connected, you're connected, you're connected, you're connected, you're connected. Yeah, how about that? Okay. And then we can move our data bus back over here. Oh, you know what I forgot to do? That's why some of this is off. If I grab all of this now and then just move it, it should be back on grid, right? Oh, I know what's going on. What I need, I never moved this one. So go back to chunky grid, highlight this, hit M. Okay. But I moved everything after I moved it, so now it's all messed up. Okay. Gosh darn it. Okay. I think I got it. I got to move them all again. Because dumb reasons. Dumb because I'm dumb, not KiCad dumb. Yeah, this is not snapping back. Oh, I hate this. So I'm aligned on this grid. So maybe this one is aligned and this other one is not. Okay. You know what? I'm just going to revert to wherever we were before. Okay. I was hoping it was before I moved stuff around. Okay. Oh, that was Sweet Tangy. Oh, hey, Sweet Tangy. In the chunky bald style. That's even funnier because I was saying your name. Can you route this with the Sweet Tangy chunky bald style? Okay. That's as far as I'm getting. That's pretty decent progress, but I think we're gonna have to redo this section, and I just don't want to. I'm not in the mood for it. So I'll probably do that during the week, and then by next week we'll be on to the next page. So, but yeah, fun times. All right. Okay. Well, no, I was going to say one thing I wanted to do was export the signals, but I don't want to do that yet. We're not quite there. I like doing it all at once because it's a lot more satisfying. So, okay, cool. Well, this is making progress. What I will probably do off stream is get these realigned because it's just tedious to go back and redo it all, and I don't feel like doing it right now. Yeah, new video, how to fix off-grid oopsies. That's kind of why I want to do this off stream, because if I do it right now, I'm sure I can figure it out, but I'm not paying attention to what I'm doing. And I'd like to actually figure this out, because this is something that always affects people, is you accidentally change the grid, or you purposely change the grid and then things get messed up. Anyway. All right. I don't think I had anything new come out this week, but if you're not following Element 14, our friend Derek, who does, his show is called DC to Daylight. He did the fundamentals of antennas. His first part came out on Wednesday. And if you're into RF stuff at all, I highly recommend you check that out. Matt has an interesting video today. And then I've got a couple articles I'll be doing this weekend. And then I've got something that I can talk about next week that's coming out next week. Can you set the challenge with setting the grid manually in Schematic is I don't think wires snap to pins. And so if you get off of a multiple of the grid, you can make things difficult to rewire. Whereas in PCB, the traces or the tracks will snap to wherever they need to. Schematic, I don't think does that. It might, and that's something I can look into, but it's a fundamental difference. Okay, I need to turn that off or recenter myself. Anyway, that doesn't matter. Okay, well, thanks for hanging out, guys. This was fun. As somebody that does streaming, I am legally required to have a Discord. So if you want to keep in touch, tell me about your projects, suggest things, let me know. I'm going to play with this later. See if I can figure it out. So, can you, I'll just do a line to grid. That's not what I wanted. I'm going to try it real quick since it's saved anyway. So like if I say select all of this, right click, align elements to grid. Okay, so I think that's going to be a way to fix the ICs, and then we'll have to go back and redo the labels. Okay, that'll work. I can make that work. That'll work out. Thanks for the suggestion. Yeah, let me play around with that, because it doesn't work quite the way I would want it to, like right now, but I'll worry about that later. So cool. Hey, Proton. Yeah, sorry, I'm done. I'm going to eat something and then not use my brain for a little while. So, all right, guys. Hope you all have a chance to do something fun and something you enjoy. Have a good weekend. I will see you guys on next Friday. So wherever you are in the world, if you subtract 3 hours from the current time, that's when I'll stream next week. All right. See you later. Bye.